All right, if you've ever found yourself staring at a loading screen that just refuses to budge, you know exactly how frustrating it is when the web just completely stops working. In this explainer today, we're going to demystify the hidden and, honestly, incredibly fragile infrastructure of the internet. We tend to think of the web as this invisible, flawless cloud, right? But the reality is vastly different. We're going to break down exactly what happens behind the scenes when the sites we literally rely on every single day suddenly go completely dark. Section 1. The day Facebook disappeared. Okay, let's dive into this by looking at what is probably the most infamous modern example. Let me take you back to one specific morning in October 2021. Entirely without warning, Facebook, Instagram, and WhatsApp completely dropped off the internet. I mean, they didn't just load slowly, they vanished. And it really forces us to ask this central question: what actually happens when the internet breaks? This was essentially a locked-room tech mystery happening on a global scale. How does a company with effectively infinite resources just cease to exist online for 6 straight hours? To truly wrap your head around the magnitude of this event, just think about this staggering number: 3 billion. That's the number of people globally who were suddenly completely cut off from their apps, their communications, and honestly, for a lot of businesses, their entire livelihood. A massive chunk of the planet's communication infrastructure just went dark in an absolute instant. Section 2. Crashing the physical internet. To understand how a global outage like that actually happens, we've got to peel back the first layer. We throw around terms like cyberspace and the cloud, but the internet isn't magic, you know? It's tangible. So let's start with the absolute basics: a server. Servers are really just physical computers sitting in massive warehouses located all around the world. All the photos, the code, the databases for any given website, they actually live on those physical hard drives. So the absolute crucial point here is, if those physical machines crash, or if they lose power, the website goes offline. Period. And one of the most common ways these physical servers crash is through sheer exhaustion. Think of a traffic overload, kind of like a massive crowd at one single door. Imagine a huge viral moment or a highly anticipated product launch. Suddenly, you've got millions of visitors trying to access the exact same physical server at the exact same millisecond. It's literally like 10,000 people trying to squeeze through one regular-sized doorway all at once. The system gets completely overwhelmed and just collapses under the pressure. Section 3. DNS and routing failures. But, a traffic jam wasn't what took down Facebook. Let's move to our next core concept and see how this builds, focusing on the invisible connectors of the web. Because it turns out the Facebook outage wasn't an explosion and it wasn't a crushed server. It was actually a mapping error tied to DNS, or the domain name system. You can think of DNS as basically the internet's phone book. When you type a name into your browser, DNS is what actually helps your computer find the physical location of that website's servers. If this phone book breaks or gets deleted, your browser's completely blind. The physical servers might be sitting right there, perfectly fine, humming along, but no one on Earth knows how to actually reach them. And this brilliantly illustrates exactly what DNS does. We humans, we like to read facebook.com, right? It's super easy to remember. But computers, they need a highly specific IP address, like 157.240.22.35. DNS is the system that instantly translates that human word into the exact computer number. Which leads us to this fascinating, honestly almost true crime level timeline of the 2021 outage. Step 1, a configuration change was made to something called BGP, which is essentially the internet's overall routing system. Step 2, this bad configuration accidentally told the entire global internet to withdraw all routes to Facebook's servers. They basically deleted themselves from the map. Step 3, Facebook completely disappears. And then step 4, which is just almost unbelievable. Because Facebook's internal tools ran on their own network, their engineers were literally locked out of the very systems they needed to fix the problem remotely. One tiny configuration change triggered this massive cascading catastrophe. Section 4. CDNs and cascading collapse. That whole concept of a cascading failure really forces us to zoom out a bit and look at how incredibly interconnected and therefore fragile the rest of the web truly is. A huge part of that interconnected web relies on CDNs, or content delivery networks. These are massive systems specifically designed to spread a website's files across servers all over the globe. The main goal here is speed. So if you're in London, you load the site from a London server, not one all the way in California. It's a genuinely brilliant system for efficiency, but it creates a massive single point of failure. And if you want proof of that, just look at June 2021. Fastly, which is a major global CDN, experienced an outage. And because so much of the internet heavily relies on Fastly's shared infrastructure, when they went down, hundreds of massive sites went completely dark at the exact same time. We're talking Reddit, GitHub, Spotify, all knocked offline in an instant. And not because their own servers broke, but because the delivery network they all shared just collapsed.
Section 5, DDoS versus human error.
So who's actually to blame when these massive collapses happen? Well, let's set up the contrast between malicious, targeted attacks and the much more mundane reality. You've probably heard of a DDoS attack in the news, right? This is when malicious attackers intentionally flood a server with millions of fake requests. It's basically the digital equivalent of jamming a mailbox with millions of fake letters so the real mail absolutely can't get through. It just completely overwhelms the target until it breaks. But here is the major twist that completely blew my mind when I first learned it. While DDoS attacks make for, great spy movie headlines, the vast majority of major outages aren't actually caused by rogue hackers sitting in a dark basement. The real culprit? It's just human error. It almost always traces back to a very mundane misconfiguration, a simple typo in the code, or just a bad update pushed by an engineer who honestly just made an honest mistake.
Section 6, how to prevent outages.
All of this brings us to a really vital question. How on earth do engineers keep these incredibly fragile systems alive? Well, the golden rule of preventing outages is redundancy. Big companies like AWS, for example, build massive amounts of redundancy into their infrastructure. This means having backup servers totally ready to go, splitting data across multiple geographic data centers, and implementing failover systems that instantly reroute traffic if, say, one physical location catches fire or loses power. You just never, ever want a single point of failure. Now, what's really interesting about this slide is the actual math behind system reliability. Companies agree to SLAs, or service level agreements, which publicly promise a certain percentage of uptime. But look at this. Even a highly impressive 99.9% uptime, still legally and practically, allows for 8.7 hours of complete downtime every single year. The internet is literally never designed to be 100% perfect. So when that allowed downtime inevitably hits, communication is absolutely key. This is exactly why companies rely on entirely independent public status pages. For example, if GitHub goes down, you check status.github.com. These pages are intentionally hosted on completely different networks so that when everything else goes totally dark, companies still have a flashlight to communicate with the public. And once the immediate fire is put out, well, that's when the real work begins. Let's walk through these steps. The outage occurs, the immediate issue gets patched, and then, crucially, step 3, the engineering team writes a blameless post-mortem. And I love this concept. It's not about pointing fingers or firing the poor engineer who made a typo. It is entirely about deeply understanding the root causes so they can rebuild the system to prevent that specific human error from ever happening again. And I think that perfectly sums up our journey today. The technology you rely on is more fragile and more fascinating than you think. Seriously, it's an absolute miracle it works as well as it does. Thanks so much for joining me on this explainer. Make sure to subscribe so we can keep decoding these digital mysteries together. And I'll leave you with this thought. The next time your screen freezes, ask yourself, is it just your Wi-Fi acting up, or did a single typo just break the entire internet?